not even chapter 1 yet, just the prerequisite chapter. So when you see P1 and P2 over the next, couple weeks, that's why. So just starting really basic vocab. A set. A set is a collection of objects called, does anybody know? Starts with an E. L. There's a periodic table of them. Elements. Okay. So a set is just a collection of objects called elements. This set notation are these curly brackets. This right here, 1, 2, 3, comma, dot, dot, dot. This is the set of, does anybody know what number set this is called? We have real numbers, rational numbers, integers, whole numbers. Does anybody know what this set is? Just 1, 2, 3, and so on? Come on. Not whole numbers. Whole numbers include 0. That's the only difference. This particular one clearly obviously starts with 1. There's actually 2 names that could fall under. Oh boy. Natural numbers? Or that's like the professional math name for it, but I definitely know in elementary school sometimes they were called counting numbers. But natural makes sense to me too, because it's just naturally where you start counting. What are numbers? 1, 2, 3 would probably be the majority of people's answer. So set builder notation, you did a decent amount of this last year with Mrs. Zigai in Algebra 2. So this says the set of all x's, so the curly brackets indicate that it's a set. The set of all x's such that this vertical line, when you read it, means such that. Such that x is a whole number. So this set, the way it's written, is equivalent to this set, 0, 1, 2, comma, dot, dot, dot. Both of those are the set of whole numbers. This one's kind of given explicitly. This one's given lingually. The empty set. There's 2 symbols for the empty set, which means there's nothing in it, right? Sometimes when we solve an equation, when you get like no solutions. Did Mrs. Zigai have you write your answer in either one of these forms? She did. Which one? Curly brackets. Okay. This means the same thing, the empty set. So you know those notations. And a subset is a set within a set. So, for example, these are the whole numbers. A subset of the whole numbers are the natural numbers, because the natural numbers are all included within this larger set. So that's just one example. If you get away from math and your set is dogs, obviously a subset would be golden retrievers, is a subset of dogs. Okay, so just a set that is entirely within another set. You guys have definitely done Venn diagrams, right? Have you ever seen Venn diagrams where it's like, there's one circle? Obviously you've seen something that's like overlapped, I'm sure, but like something with like a circle within a circle, that's your subset right there, okay? Something that's entire, this would be a subset of this. Okie doke? Easy stuff. Okay. How about these symbols? You did those last year with Mrs. Zigai? Yes? In what context? Do you remember? I'm even trying to think with my Algebra 2s. I feel like I did them. I just don't really remember. Yeah. But was it like, it wasn't probability. Statistics? Yeah. Okay. Yeah. Can't remember. Anyway, flip back my Algebra 2. Anyway, so we know that intersection is kind of the upside down U, and union means U. So when you have set A, capital letters, signify kind of the title of a set. Set A and its intersection with set B, you're essentially looking for where they overlap. Oh, yeah, you did it with Venn diagrams, I'm sure, right? So this right here, if this is set A and this is set B, then this section right here is the intersection. It's any element that belongs to both would be in the intersection. So all x's such that x is an element of set A and also of set B. Okay, so intersection kind of can be read as and a lot of the times, and then union can be read using or. A union with set B is the set of all x's such that x is an element of either A or B. Or both, right? The union is all three of these sections. Just A and B, and the just B's. Okie doke? What if I call this C? This little circle is C, and this little section is D. Could you tell me what is this? If this big circle is B and this little circle is C, what would be the answer here? Raise your hand when you think you can tell me. Think about it. Come up with your best guess. I'm going to elaborate a little further because I'm a little bit surprised that I only see two hands. That symbol means all x's such that x is an element of both sets. Where are the items in this picture that are elements of both of these sets? What's your name? Mitchell? What is it? Just C, exactly. The intersection of this circle and this little section is just that C section. It's a little bit tricky. What about if I said B union C? Raise your hand when you think you can tell me what that is. Union means we're looking for all the areas that are elements of either or. Joe, what do you think? That's just B, exactly. And by saying B, you're obviously, in and of that itself, you're including C. So those are kind of trickier circumstances of those symbols. Maybe using them a little bit differently than you did last year. So those, like I said, those are the trickier examples that just came to me, and I went with it with you guys. This is more straightforward. If you're just looking for the intersection of this explicit and finite set, what do I mean if I call this a finite set? What do I mean by that if I call it a finite set? What's your name? Trista? What do I mean if I call this a finite set? Right, there's not, it's the opposite of infinite, exactly. I can actually quantify that there are 5 elements in that set. So this finite set of 5 elements, this finite set of 4 elements, we're looking for where there is an intersection or where they kind of have a commonality. So definitely a 3, not a 4, not a 5, not a 6, but again a 7. So the intersection of this is the finite set of just 3 and 7. How about the union of odd integers and even integers? And maybe it would help here if you kind of listed out to kind of visualize what's going on here for, well, let's actually back up. Do you guys know what integers are? Let's go there. We've talked about natural. We've talked about whole. Let's go up here and talk about what are integers. Anybody? Come on. You see that word in math. all the time, you probably clearly take it for granted if you can't tell me explicitly what it means. What's your best guess, Sarah? What's an integer? I appreciate the guess. It's incorrect. There can be negatives. Correct. Full numbers, for lack of a better word, maybe whole numbers, no decimals. It's really the whole number set along with all of its opposites. 0, 1, 2, 3, 4, 5, and also -1, -2, -3, -4, -5. Okay? So integers are, the best way to show them in a set form is probably by starting with the dot, 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 doing like a -3, -2, -1, 0, 1, 2, and kind of ending it with a dot, dot, dot. So now that can take us back to here and back to the point I was trying to make. If we visualize this, odd integers are like -5. There's a dot, dot, dot there. -5, -3, -1, 1, 3, 5, dot, dot, dot. Those are your odds. Your evens are -4, -2. Is 0 an even number? That's a good survey. If 1 means yes, 0 is even, and 2 means 0 is not even, it's kind of a special case. Hold up yes or no on the count of 3. 1, 2, 3. A mixture. 0 is an even number. Should have been a 1. Okay? So maybe I made you overthink that, but sometimes that's what happens. So -4, -2, 0, 2, 4 are evens. Andrew? That doesn't include all real numbers, because what about 1.5? All integers. Yes, good. I'll just do it in set notation. The set of all x's such that I have a little new notation for you. Write this down and I'll elaborate in a second. Does anybody know what I mean by that? The set of all x's such that math language. Okay. So number sets, these common ones, natural numbers, whole numbers, rational numbers, irrational numbers, they all have like a capital letter notation. So for example, and I'll use the bottom left corner to do this, natural numbers, it's kind of like a capital N, but it's got like a double thing there. We can pull up the textbook and show it to you like in print. Whole numbers is just like a W. And these is just international math symbols. If you went over to Finland, this is the way that they would be writing. Math is one of the few languages that is really truly international. Integers, weirdly, is a Z. Rational is an R. Some of them are obviously self-explanatory. Others, like the integer symbol, I don't really know where that Z comes from. I've never really researched it. I've just always just known that that's what that is. My guess is that in some other language, their word for integers probably starts with a Z. Kind of like how slope is like M. You know how slope is identified with an M. That's my theory on that as well, although I don't really know. Does anybody know for sure why slope is used in M? And the other type of number is irrational. is a Q. I wonder why that's not an I. I don't really know. I'm about to Google it. But I have a guess. I have a guess because I'm thinking maybe I is reserved for another number set. I'm guessing. I don't know. Let's Google it. What is symbol for imaginary number set? Oh, well, we know they just use the lowercase I for that. Huh. Wait a minute. I think I just taught you wrong. I think I did. Hold on. This won't be the first time or the last. Or no, I'm just kidding. It is the first time. It won't be the last. Rational is R. Irrational. No. Hold on. What is the symbol? We got natural, integer. Is rational, R is real. I didn't plan on teaching you this today. I'm going to come back to this because I gotta get my ducks in a row. I kind of forgot. And since I've forgotten, you can take the hint that it's not going to be that important for this year, but just so you know. Does anybody know? I know these are right. I think I just screwed these up. Rational is real is R. I'm going to add that. I think I'm pretty sure about that. It's this one and this one I have to double check on. Don't worry, it's coming to you live by the end of the period. I'll get you that answer. Because I don't want to run out of time. Absolute value. You guys obviously all know what absolute value is. This is actually kind of like a piecewise function. The way that that's written, I know you all know what absolute value is, but the notation that you start to use in pre-calc and calc just gets a little bit more professional. And so they define an absolute value using a piecewise function. When x is greater than or equal to 0, the absolute value of x is just x. Makes sense, right? And when x is less than 0, the absolute value of x is going to be the opposite of x. For example, if x is -7, that qualifies as being less than 0, so the absolute value will be -7, which we all know to be 7. So just rather than saying in words, just make it positive, right? Or the distance away from 0, which is technically what all of this means, it kind of gives it to you in a more mature and symbolic international math language sort of presentation. Simplifying, very straightforward. I know after Algebra 2 this should be pretty clean. The first step here is going to be squaring this binomial. I'm hoping that you guys are able to square binomials without actually having to expand and write out. But if you have to, that just makes you more comfortable to see 2x plus 5 times 2x plus 5, and it helps you to see it that way before you actually, square it and write down your final answer. That is fine. But we get 4x squared. That's just our first term squared. Where does the middle term come from? What's the shortcut to get from just looking at this to the middle term? Uh-oh. What do you think? You don't know? Okay. Right. You multiply those together and you just double it. Essentially because 2x times 5 is going to give you a 10x on your outer, and 5 times 2x is also always going to give you the same thing, 10x on your inner, and you have two of them. So if you just multiply these and get 10x, the middle term is just going to be double that. And then your last term obviously is 5 squared, which is just plus 25. And then I'll distribute the 10 while I'm at it, so that's going to be a 40x squared plus a 30x. Distribute that 6 now, 24x squared plus 120x plus 150. And then combine our like terms. So what do we have? 64x squared. 150x plus 150. And simplify means just that. Distribute, combine like terms. Simplify does not mean factor. In fact, factoring and simplifying are opposite operations. Okay? So you would not just go and like take out a 4. Well, 4 wouldn't even go into 150, so a 2. You would not do that. Simplify means distribute, combine like terms. On our next one, just a little bit more complicated because we've got parentheses within parentheses, in which case I always say work from the inside out. So you go to your x minus 2, innermost set of parentheses, you got a negative in front of that, which is going to get distributed. So you're going to have minus x, and then when you subtract a negative 2, it turns into a plus 2. And you have an option here in those parentheses. You can combine the 7 and the 2 to get 9 first and then distribute your 4x, or you can distribute your 4x now and combine later. I'm going to just distribute my 4x now. And then combine like terms. Negative 4x squared should lead. 36x plus 6. Any questions? Simple enough. Okay. Take the next 4 minutes or so to do these 2 problems on the back. And while that's happening, I will get back to you in one. No, because that would be factoring. You're factoring and simplifying the opposite. So simplify just means distribute by like terms. someone's. I don't know whose this is. One of the threes. Take a look at that final answer. Raise your hand if you agree with that. If you got that same thing. No. Okay, well then this is our next game. It's called Play Teacher. And sit through that work, and once you find their mistake, raise your hand, and once enough of you have found it, once you find it, just put your hand up, keep your hand up so I know. Very good. The negative was not distributed. You know what? And this is common. Whoever's this is, they tried to do too much at once. They tried squaring this in their head. Well, I guess they didn't really do it in the head, which is fine. They squared it first, which is absolutely the first step. And either they thought they distributed this negative sign, or they just didn't even think about it. They squared it and lost their parentheses. Those parentheses cannot be lost because what technically should be there is a minus a trinomial, in which case we all know that needs to be distributed. So it should be a minus 16y squared. This negative 40y, when you do a minus negative 40y, would have become a plus 40y, and the plus 25 with the minus would become a minus 25. And then that's going to really affect a lot, because now instead of 3 plus 25, it should have been 3 minus 25. And 28 is quite a bit different than negative 22, right? And so the domino effect, and their answer looks probably way off from what it's supposed to. So that combo, 3 minus 25 would be a negative 22. Ooh, what else did they do wrong? Andrew? Absolutely. They did subtraction before they did multiplication. This is 7 minus 4 times brackets. 4 times brackets absolutely has to come prior to subtraction. And believe me, I literally just talked to my Algebra 2 kids about this. I kind of got ahead of it with them. I didn't necessarily expect you guys to do that, but I did tell them this is a mistake that gets made from 9th grade right through calculus, and it's painful for me because, you know, but 7 minus 4 is just so inviting. We're just trying to simplify things. So this should be different. Let me look at this person's. They also did the 7 minus 4 first. Uh-oh, we're 0 for 2. This person has it right. So they distributed their negative 4 through, and I'm just going to trust their multiplication and their combining of like terms. Does that look right? Raise your hand if you got that answer. Okay, very good. Okay, on the next one here, distribute your 7x squared minus 14 plus the 4 gave them the minus 10. They left everything else the same. They should be distributing their negative next, which they did, and then just combining like terms. That's golden. And the last one was just 2, which I see we did a pretty good job on. All right, guys, my bonehead move. I is for irrational. Here it is in your book. I is for irrational. Rational is Q. So whatever I did on the front, I screwed that up. Rational is Q because the R is saved for real, and irrational is I. We're not going to lose sleep over it. But just really lastly, going back to that notation, this is another way of saying the set of all x's such that x is an element of the integers, the set of integers, okay, such that x is just an integer. Okay, and you'll see that it's just international math language. So here's your homework, pages 14 to 17, numbers 1 through 125. Clearly you're not doing that. 1, 5, and 7, when you see that in parentheses, that means anything that ends in a 1, 5, or 7. So you have to do 1, 5, 7, 11, 15, 17, 21, 25, 27, right? Because I want you to cover all the sets of different instructions, but I don't necessarily want you doing the odds because there's an astronomical number of those. Okay? Are we good? Any questions?